Hi, I'm Amelia Schaefer. I'm a senior psychological sciences major at UConn and a health research program intern under Dr. Burkhard at UConn Health. And this is Could a Simple Blood Test Detect Tinnitus? Serum prestin as a potential blood biomarker for sound-induced tinnitus. So what is tinnitus, you may be asking yourself? Well, tinnitus is the perception of sound without any external auditory stimuli, and it is often perceived as a ringing or a buzzing. You probably know somebody who has tinnitus, or you may even have tinnitus yourself. It affects millions of people, particularly those exposed to loud environments. The root cause of tinnitus remains unknown, and there are currently no definitive tests or treatments for it, making it a very difficult and emotionally draining disorder to live with. Recent studies suggest that prestin, a protein found in the outer hair cells of cochlea, could serve as a potential biomarker for various auditory disorders such as tinnitus, providing insights into health and function of outer hair cells. Prestin helps play a vital role in hearing and sound amplification. So based on these findings, this study hypothesizes that a decrease in prestin levels will be seen in mice with sound-induced tinnitus. To induce chronic tinnitus in this study, we followed 6 steps, those being an acoustic recording, behavioral training, sound exposure, another acoustic recording, behavioral testing, and a terminal blood draw. I'll discuss these more in depth in my methods section, but first I want to discuss my study design a little bit more. In this study, we utilized CBA-CAJ mice of either sex. We used this strain of mice because of their great hearing profiles and because they are less susceptible to hearing loss as they age due to natural causes. Because this is an auditory study, we wanted to eliminate any hearing loss other than that caused by sound exposure. We had 3 groups of mice in this study, first being the control group 1, so mice who completed a hearing test, then being measured for their prestin level. Then we had control group 2, who were mice who had their hearing tested, then had behavioral training, and then they were measured for their prestin level. Finally, we had our tinnitus and non-tinnitus mice who had their hearing tested, completed behavioral training, sound exposure, tinnitus testing, and then they were measured for their prestin level. Below, you can see a frequency profile for a mouse with tinnitus versus without tinnitus being tested in our active avoidance paradigm before and after sound exposure. As you can see, the mouse with tinnitus seemed to have the tinnitus at a frequency of about 18 kilohertz as they scored less of a percentage correct in avoiding that frequency in our active avoidance paradigm. Moving on to our methods, for our functional hearing assessment, we utilized auditory brainstem response and amplitude modulation following response, in which the mice were anesthetized. Any mouse with poor hearing was excluded before behavioral testing, and then following sound exposure, mice with bilateral hearing loss were excluded, and we also tested for single ear hearing thresholds. For our behavioral testing, we utilized active avoidance, which is a learned behavior paradigm, and it involved daily testing of the mice, the presentation of pure tones ranging from 8 to 32 kilohertz preceding inversive shock stimuli were involved, and we had to have the mice learn that the tone warned of an imminent shock and that silence was considered safe. In order for the mouse to move on to the sound exposure, they had to meet a success criteria of 75% avoidance for 3 to 4 consecutive training days at both 70 dB SPL and then at 60 dB SPL. Any mice who failed to meet this criteria were dropped from the study, and then the same testing was performed once or twice a week to distinguish tinnitus from non-tinnitus mice following the sound exposure. And so those frequency profiles, which we were looking at under the study design, are how we would distinguish the tinnitus from non-tinnitus mice, and that's the data we collected from active avoidance. For our sound exposure, we would expose our mice for 1 hour to continuous narrowband noise at 113 to 116 dB SPL at 15 to 17 kilohertz. The mice had 1 earplug in which we noted which ear was put in, and then sound was coming at them from both sides. We would typically expose 2 mice of the same sex at the same time, and we would also videotape them. Mice were then housed for 4 to 8 weeks post-sound exposure for tinnitus induction, and then no testing of any sort occurred during this period. And then finally, for our terminal blood draw, we would deeply anesthetize the mice, and a cardial puncture would be performed. And then we would collect the blood and then put it in the centrifuge in order to spin out the blood serum. And then we would collect that and hold it at negative 70 degrees Celsius until further processing. We have yet to utilize our enzyme-linked immunosorbent assay kits, otherwise known as ELISA kits, and those will be used to measure the prestin levels in the blood serum samples. So moving on to some preliminary results, we first have audiograms for representative example mice utilizing our ABR and AMFR prior to behavioral testing and sound exposure differentiated by sex. So these are our baseline hearing thresholds, which is some nice data to have. And then next to that, we have the mean and standard error of the mean for these audiograms. Below, we have the overall training profile for a representative example mouse at all frequencies. presented at 70 dB and then 60 dB SPL over 15 training sessions in our active avoidance paradigm. So as you can see, as the number of training sessions increases, so does their success rate. So the number of sessions they have correlates with their percent avoidance. Once this mouse hit at about 9 sessions, they were about ready to switch to the 60 dB SPL. So they were at about 75-80% correct. So you can see that's why there was an increase in avoidance and then it kind of flattened out. That's when we switched to the 60 dB SPL. Next to that figure, we have our frequency profile for that same mouse at 60 dB SPL in their behavioral training. So you can see that they're meeting the training criteria necessary in order to move on to sound exposure. So again, this is what we're looking at when we're performing behavioral training in order to know if the mouse is ready to move on in the study. And then finally, we have audiograms for representative example mice utilizing the same ABR-AMFR post-sound exposure differentiated by sex. So we can see a shift in the hearing threshold, and it's slightly elevated, and we see that a bit more in the male mice than the female mice. But again, it's just some nice data to have. It was expected to see a shift in the hearing thresholds, especially in the male mice. So based on this, we could in the future move on to studies looking at sex differences in central gain, as well as sex differences in neuroinflammation and microglial expression. That's something we've been working on lately in a study looking at PLX5622 and how that affects auditory function in mice, the same CBA-CAJ strain that we utilized in this study. And then also some more steps that we could take that pertain more to this study would be getting the serum prestin analyzed. They've been waiting to be analyzed just because we don't have enough samples yet. We ran into some issues with hemolysis with our blood samples, and we just haven't had enough mice to actually sacrifice for the study. I did run into some issues with the behavioral training and testing in which the active avoidance paradigm had some mechanical issues, which could have caused a little bit of a delay in our training and just the study in general. But overall, this process has really taught me a lot about research in general and being meticulous with data collection. And I've really enjoyed my time working in this lab with Dr. Burkhardt, and I've learned so much. And I'm so thankful to everyone who has watched my presentations that I've given on this. And if you have any questions, please feel free to email me. I've listed both my UCHC and UConn email up at the top.